Welcome to another episode of AI Frontiers, where cutting-edge artificial intelligence research is explored through dense academic papers transformed into engaging stories. Today's focus is on language AI breakthroughs, synthesizing 17 papers from October 25, 2025, highlighting reliability, inclusivity, and efficiency in AI. This presentation dives into language AI innovations, journeying through 17 recent papers on AI's language frontiers. Themes such as benchmarks, multilingual tools, and reliable generation are uncovered. The structure builds from field basics to future visions, sparking curiosity. Standout studies and real-world impacts are highlighted, ending with AI tools used and a call to subscribe. Computation and language, tagged as cs.CL on the arXiv preprint server, represents the vibrant intersection of computer science and linguistics, where machines are built to understand and generate human language. Systems like chatbots, search engines, and voice assistants that power daily lives are created, drawing from artificial intelligence, machine learning, and cognitive science. Meaning is extracted from vast data, breaking down cultural barriers and making information accessible. These 17 papers highlight dynamism in the field, focusing on hallucination detection in scientific writing and eco-friendly models that rival large ones without high energy use. Inclusivity, reliability, and efficiency are emphasized, addressing challenges like low-resource languages and biased outputs, pushing boundaries in multilingual processing, personalized interactions, and trustworthy generation with sustainability and ethics in mind. A strong emphasis is placed on creating benchmarks and datasets for underrepresented areas, ensuring AI can be rigorously tested in diverse contexts. For instance, the CAP dataset is introduced for spotting hallucinations in scientific texts across 9 languages, including low-resource ones like Bengali. Another benchmark, this Judge Bench, is presented for evaluating the aesthetics of data visualizations, ensuring charts convey truth accurately. This theme is crucial because without solid benchmarks, AI improvements remain guesswork. These tools reduce guesswork, enabling better AI in diverse contexts like low-resource languages. Multilingual and low-resource language processing stands out, tackling the digital divide for languages with scant data. A benchmark for irony detection in Urdu is presented, achieving high accuracy with models like Llama 3. A sentiment analysis dataset for Maithili, an Indo-Aryan language from India, is introduced, using synthetic generation to fill gaps. Advancements in multilingual target stance extraction across languages are also covered. It's about making AI truly global, not just English dominant. Advancements in retrieval augmented generation, or RAG, and embeddings are prominent, enhancing how AI fetches and represents knowledge. Fair RAG is proposed, which iteratively refines queries for better question answering. Giga embeddings are developed for efficient Russian text representations, showing how these techniques reduce errors and boost relevance in tasks like search or dialogue. The technical concept of embeddings involves mapping text to vectors, capturing meaning for search, like semantic fingerprints. Personalization and steering of large language models is a key thread, focusing on tailoring AI to users without losing control. SteerX is introduced for disentangling preferences in outputs. Studies show that simpler prompts work better as models scale up. Error detection and evaluation ties it all together, with works on estimating error rates in text comparisons or metrics for German text simplification, ensuring AI outputs are clear, faithful, and bias-free. These themes overlap seamlessly. For example, RAG often feeds into hallucination detection, and multilingual benchmarks support personalization in diverse cultures. Key findings from the synthesis include several critical insights. Hallucination detection is getting a multilingual boost. The CAP dataset revealed that large language models hallucinate more in scientific contexts due to jargon and reasoning gaps, with error rates spiking in low-resource languages, but it enables detection tools that cut inaccuracies. Specialized models outperform general ones in niche tasks. This judge slashed errors in visualization assessments by 20% and aligned better with human judgments. For low-resource languages, fine-tuned models like Llama 3 hit F1 scores over 94% in Urdu irony detection, far surpassing traditional methods. Iterative RAG systems like FAIR RAG improved multi-hop question answering by over 8 points on benchmarks, by filling evidence gaps dynamically. Eco-friendly alternatives like memory-based models in OLIFANT match neural nets in accuracy while using less energy and offering transparency, scaling log linearly without GPUs. Methodologies powering these innovations include several common approaches. Fine-tuning large language models adapts pre-trained behemoths like BERT or Llama to specific tasks with targeted data, as seen in Urdu irony detection or clinical named entity recognition, offering rapid performance gains but with risks of overfitting and high computational costs. Retrieval-augmented generation fetches external knowledge to ground responses, like in FAIR RAG's iterative refinement, excelling at reducing fabrications but potentially slow with noisy retrievals. Contrastive learning for embeddings trains models to cluster similar texts and separate dissimilar ones, as in Giga embeddings for Russian, powerful for semantic search but demanding quality examples. Synthetic data generation uses AI to create annotated datasets, employed in mightily sentiment analysis, scaling quickly but risking biases. The technical concept of fine-tuning involves tweaking model weights on specific data, like customizing a recipe. The first selected paper is by Federica Gamba and colleagues, titled Confabulations from cs.CL Publications, or CAP, a dataset for scientific hallucination detection. It is selected for its novelty in multilingual hallucination benchmarks. AI fabrications in science are addressed across 9 languages, including low-resource ones like Bengali and Telugu. An annotated dataset is provided for detection tools, reducing misinformation risks. The impact enables equitable AI for global research, highlighting equity gaps. It represents the reliability theme with real-world applicability in high-stakes fields. The dataset includes 900 scientific questions from cs.CL publications, generating over 7,000 answers from 16 models, with annotations for hallucinations and fluency. Findings show higher hallucination rates in low-resource languages, up to 30% more in Bengali than English. The second selected paper is by Muhammad Aghajani ASL and colleagues, titled FAIR RAG, Faithful Adaptive Iterative Refinement for Retrieval Augmented Generation. It is chosen for its innovative iterative RAG, improving complex question answering. Evidence gaps are filled dynamically, boosting accuracy by over 8 points on benchmarks like Hotpot QA. The novelty transforms standard RAG into an adaptive system for faithful outputs. The impact reduces hallucinations in knowledge tasks, influencing search and education. It exemplifies retrieval advancements for trustworthy AI generation. The framework uses a structured evidence assessment module and adaptive query refinement, achieving F1 scores of 0.453 on Hotpot QA. The third selected paper is by Tianong Gao and colleagues, titled Ola Mind, Towards Human-like and Hallucination-Safe Customer Service for Retrieval Augmented Dialogue. It is selected for bridging theory to industry in empathetic dialogues. RAG is combined with expert imitation for safe, natural customer interactions. The novelty achieves 28% resolution gains and hallucination reductions in settings like live streams. The impact is scalable for e-commerce, promoting ethical and efficient AI. It represents personalization and dialogue themes with practical innovation. Methods involve learn to think and learn to respond stages, with A/B tests showing resolution gains of 28.92% in community support. Future directions point to exciting paths, like hybrid models merging memory-based efficiency with neural power for greener AI, or expanded multilingual benchmarks to cover more languages and domains. Challenges include scaling personalization without biases, reducing computational footprints, and ensuring ethical data use in synthetic generation. Surges in multimodal systems incorporating voice and images are anticipated, along with AI that self-evaluates hallucinations in real time, addressing inclusivity gaps for global adoption. Collaborative efforts on edge computing are suggested to overcome computational challenges. This synthesis was created using AI tools, including GPT-Grok using model Grok 40709. TTS synthesis was performed using Google, and image generation using Google. Content underwent review by a human expert. It is important to acknowledge that some oversights may still exist. All references are provided for verification. Subscribe to the YouTube channel for more AI research insights. The title is AI Frontiers. Stay updated on cutting-edge papers and narratives. Hit subscribe and turn on notifications today. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from arXiv preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer. This video uses arXiv preprintserver.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv preprintserver.org.